We begin our series of tutorials on arithmetic, and our first tutorial is about numbers. We will talk about natural and integer numbers, rational and irrational numbers. We will learn how to write rational form of the number, having its decimal form, and we will know what is the real numbers and real line. Let's get started. Arithmetic is the science of numbers. Greek word arithmos means number, and arithmetic is about elementary properties and rules of calculations for numbers. For deep properties of numbers, we have a very important branch of mathematics called number theory. Let's begin with numbers. First of all, let's define what is the natural numbers. Natural numbers is the set of, in mathematics, these curly braces stand for the set of. So natural numbers is the set of numbers 0, 1, 2, 3, and so on. It's very important to understand that sometimes natural numbers are defined as the numbers 1, 2, 3, and so on without 0, but I prefer to define natural numbers with 0. Natural numbers appeared when primitive man was counting his animals, cows, and other people, or even maybe wives. Maybe primitive man was counting his wives, telling, I have no wife, I have one wife, 2 wives, 3 wives, and so on. Next, let's talk about the concept of integer numbers, and let's define what is the integer numbers. Integer numbers, denoted as z, integer numbers, is the set of numbers. Like natural numbers, it also has 0, 1, 2, 3, and so on, but beside, it also has negative numbers, -1, -2, -3, and so on. From the definition, we can see that every number in the set of natural numbers is inside the set of integer numbers. So each element of natural numbers is inside integer numbers. That's why natural numbers is the subset of integer numbers. And in mathematics, we write that n, natural numbers, is the subset of integer numbers. And in mathematics, this symbol stands for subset of. Natural numbers is the subset of integer numbers. Next, we define the concept of rational numbers. Rational numbers, denoted as Q, rational numbers, is the set of numbers represented as P over Q, where P is an element of integer numbers. Once again, in mathematics, this symbol stands for element of. So P is element of integer numbers, or P is integer, and Q is natural. Once again, the set of rational numbers is the set where each element can be represented as a fraction P over Q, where P is integer and Q is natural. From definition, it's obvious that any element of the set of integer numbers, for example 3, is inside, and 2 and -1, any element, is inside the set of rational numbers, because we can write -3 as -3 over 1. So this is also rational numbers. And we can write that integer numbers is subset of rational numbers. Let's give examples of integer numbers. Examples are, for example, 1 over 2, -1 over 2, 3 over 4, -3 over 4, 9 over 44, and so on. We have very important result for rational numbers. Let's write it, result, that let's talk about what is the decimal representation For example, 1/2 has a decimal representation of the number 0.5. If you calculate using calculator and divide, and 1/2 will be 0.5. Minus 1/2 is minus 0.5. 3/4 is 0.75, and this is minus 0.75, and this number is 0.20, 45, 45, 45, and so on. And here, 45 will be the period. Take the calculator and check it. So this is a decimal representation. And the first case is that, the result is that any rational number can be represented as a decimal number of two cases. And the first case is that it has a finite number of digits in its decimal representation. For example, 1/2 is 0.5, so it has one digit after floating point. 3/4 is 0.75, so it has two digits after floating point, and so on. And in the first case, any decimal representation of the rational number has a finite number of digits in its decimal representation. The second case is that it can also have infinite number of digits in its decimal representation, like 9/44, which is 0.2045, 45, 45, and so on. And 45 is a period. So it has an infinite number of digits in its decimal representation, but it has a period. So these two cases are anomaly cases for rational numbers. Or we have finite number of digits in its decimal representation, or it's infinite, but we have a period. It's clear. Okay, let's assume a example. Let's learn how to write rational representation of the number when we know its decimal representation. For example, we have a number x, which is equal to 0.123 456 456 456, and so on. And assume 456 is a period in its decimal representation. Let's write its rational representation of this number. For this, we multiply the both sides of this equation to 1000, and we will have 1000x equal to 123.456 456 456, and so on. And when we multiplied to 1000, our floating point moved from this place to this place. And next, we perform a subtraction and write 1000x minus x is equal to 123.456 456 456, and so on, minus 0.123 456 456, and so on. And if we subtract the second number from the first, we see that infinite tails of these two numbers offset each other, and we will have no tail as a result. So here we have 6 minus 3 is 3, 5 minus 2 is 3, 4 minus 1 is 3, here is 3, 1, 2. So as a result, we have 1000x minus x, which is 999x, is equal to 123.333. Next, we also multiply this number to 1000 because we want to move our floating point to this place and have integer number. And after multiplication to 1000, we have here 123.333, and here 999,000x. And here we easily calculate x, and x will be 123,333 over 999,000. And this is a rational representation of the number, where its decimal representation was this. And that's all. Along the same line, we can calculate rational representation of any number with infinite digits and with the period. This is the second case. And the first case is obvious. For example, if we have number x, say 0.123. In this case, it's easy to see that x is 123 divided to 10, 100, 1000, divided to 1000. And this is a rational representation of the number, where its decimal representation was this. Easy. Next, let's talk about, we already know what is the rational number and how to calculate rational form. Next, talk about irrational numbers. Irrational numbers, let's denote it like I, is the set of numbers x, where x doesn't have a representation p over q, where p is integer and q is natural. Once again, the set of irrational numbers is the numbers which are not rational and doesn't have a representation p over q, where p is integer and q is natural. Examples of irrational numbers are, the first example is number pi, which is 3.1415926535 and so on. The next famous number is number e. All of this number will be covered further. Don't worry if you don't know these constants. Number e is 2.71, 82, 81, 82, 84, 59. The next famous example is square root of 2, which is 1.41, 42, 1356, and so on. And what is the common thing in these three numbers? The common thing is that the number of digits in its decimal representation is infinite, and it doesn't have a period. Let's write it. First, infinite digits, and second, no period. No period. And it's obvious that these numbers are not of that two kinds of decimal representation for rational numbers. That is why these numbers are not rational. They are irrational. Next, let's define what is the real numbers are. Real numbers, denoted as are real numbers. At this stage of the notion of the number, when we don't know what the complex number is, we can define real numbers as a union of rational numbers and irrational numbers. And in mathematics, the symbol stands for union. So real numbers is rational and irrational numbers. We can draw a picture for better understanding. Assume this is the set of real numbers, and it consists of rational and irrational numbers. And we already know that set of integer numbers is the subset of rational numbers, and the set of natural numbers is the subset of integer numbers. In the future, we also learn what is the set of transcendentic numbers, and this set is the subset of irrational numbers. We will talk about transcendentic numbers in our session of number theory. So this is a very good picture for understanding what is the real number is. In mathematics, we also have the concept of real line. Let's draw a line, R. This line is called real line when we assume that this is a representation of real numbers as a real line. What we mean by this, we mean that any real number we assume is on this line. For example, natural numbers on this line, 0, 1, 2, 3, and so on. Negative numbers on this line. So integer numbers are on this line. We also assume that rational numbers on this line, so say 1 over 2, which is 0.5, is here. 3 over 4, which is 0.75, is also here. Along the same line, assume any rational number is on this line. Also assume irrational numbers on this line. For example, number pi is somewhere here, pi 314, and so on. Assume number e is also here, 2.71, and so on. And assume square root of 2 is also here, 1.41, and so on, and etc. So any real number has a place in this line. So this is the definition and description of the real line. It was everything I wanted to talk about for this lesson. Thank you very much, and have a great day.